All right, now we're on to the second part of the chapter, which is the mole. The mole, you might think of a cute, fuzzy little creature, but in this case, we're going to talk about number in chemistry. And in chemistry, the mole is a huge number. If you look at the number on the screen, 6.022 times 10 to the 23rd, that is 602 sextillion. Well, if you write a 6 with 23 zeros after it, that's about the same size. It's a gigantic number. It's unimaginably huge. There aren't many things that you would have in life that are that large a number. There's not that much money in the world, even with all the pennies and all the dimes and all the currencies in the whole world. There's not that much money. There's not that many cars. There's not many marbles. So we use it for counting something really small, like atoms and particles. If you want a rough idea, a mole is about a handful of most of the elements in the periodic table. It might be a small handful, might be a large handful, but it's much better than all these other things. If we had a mole of marbles, standard size marbles, it would form a mountain 116 times taller than Mount Everest, and the bottom of it would be a bit larger than the U.S. So it's kind of silly to count anything but atoms and molecules. And back to that handful thing, it's nice because it's a rough measurement. You have a mole or about a handful of any chemical. So let's see. The person who came up with that number is this handsome young man, Amadeo Avogadro. And now that we know what a mole is, we can do all sorts of different calculations. Now, the handy thing is on the periodic table, every element that you show has its big number. You might remember that we had carbon earlier, and carbon's numbers were, we put them right here next to the man, 6 and 12. Remember, 6 was the number of protons, and 12 was the number of protons and neutrons added together. Well, that 12 is its mass. And so if we had a mole or a handful of carbon atoms, remember this was the numbers for carbon, it would weigh 12 grams. Or you want to be more specific on the periodic table, it has 12.011, and that may seem really specific, but it's even rounded because remember, a mole is a really big number. So again, every element on the periodic table, we know how much a handful or a mole is for every one of those. If you look at hydrogen, hydrogen's number is 1. So a handful of hydrogen is pretty light, weighs about 1. And some of the heaviest ones, those radioactive ones near the bottom, they weigh 200 something, which is about a half of a pound would be 1 mole. Okay. Oops. So those numbers in the periodic table, we can call them the molar mass. So if you look up aluminum, find aluminum on the periodic table, it's an Al on the top right. It has a mass, we're going to call it a molar mass, of approximately 27 grams. So 1 mole or a handful of it weighs 27 grams. It's not too much. Okay? And we can also do something like, let's do chlorine. Chlorine, if you look in the periodic table, you should find that it weighs about 35.45, and we should have a G for grams units. We can also do some more complex calculations. So let's say we have 25.5 grams of carbon, and we want to find out how many moles that is. Well, we can do that pretty easily. We would write down 25.5 grams of carbon, and we might remember this from the very first unit of the chapter of the year. We put grams of carbon at the bottom automatically, and then we would put moles of carbon on the top. Now for grams, we look in the periodic table and we have 12.01, and we always write 1 for mole. We have then canceled out the grams and we're left with moles. So all we have to do now to get our answer is we do 25.5 times 1, which of course is 25.5, divided by 12.01, and we will get, keeping in mind significant figures, 2.12 moles of carbon. So that many grams of carbon is the same as just a couple of moles, just a little over 2 moles of carbon. We can also do some calculations like finding the molar mass of H2O. Well, if we look up hydrogen, it weighs 1. And there are 2 hydrogens, so we can say that those 2 weigh 2. And then if you find oxygen's mass, it weighs 16. So we add that up, and together the molar mass of water is 18 grams. So 1 mole, or a handful of H2O, weighs about 18 grams. And we could do another problem, changing 39 grams of CO2 into moles. So this sounds a little bit tougher, but like always, we write down the number and the units that were given at the start, and then we draw our lines. We automatically put grams at the bottom, grams of carbon dioxide, and then we put mole on the other end of the line, mole of CO2. We always put 1 for mole, all the time, unless the problem gives us any different number of moles, but at least we put 1. And then grams, unless it gives us grams, well, we gotta look in the periodic table. So we're going to find that carbon weighs, we'll write it over here, carbon weighs 12, and then the 2 oxygens, 2 times 16 is 32. So the molar mass of carbon dioxide is going to be 44 grams. So we're going to put 44 right up there. So that's going to help us cancel grams, and we're going to be left with moles of CO2. So we took 39 times 1 divided by 44. We're going to get 0.89 moles of CO2. Okay. So a couple things to remember. You write down the number and the units that you're given in the problem. You put those same units at the bottom of the next step, and then what you want to change it to at the top of the next step. You always use 1 for moles, and you always look for grams on the periodic table. So if you can remember those tips, those will make these problems quite simple. So let's challenge ourselves with one last fun problem. We have 4.1 moles of CO2. Draw my line. And I'm just going to automatically put moles of CO2 at the bottom. And I'm going to put grams of CO2 at the top. Now, if you remember from earlier, we're going to put 1 for mole in that step. And then grams, we're always going to look at the periodic table. We might remember from earlier that 2 oxygens weighs 32, and 1 carbon weighs 12, so we know that would add up to 44. So that's why we put 44 grams there. So we canceled out our moles of CO2. And this time we're going to do 4.1 times 44. You might remember in the previous problem we divided. And we're going to keep 2 significant figures. So we would have 180 grams of carbon dioxide. And keep in mind, whenever we do these calculations, the beginning amount and the ending amount, they are the same. It's just like changing 4 quarters into dollars, or 100 dimes into pennies. You're going to end up with the same amount. It's just that in some cases 4.1 moles will work, and in other cases 180 grams makes sense. So that's why we're switching from one unit to another. So hopefully you feel like you are good at this. If not, you can rewind and replay and rewatch and come with questions in class. Thank you for watching.